Hello everybody, it's Mr. Spinelli bringing you a quick lesson on implicit differentiation, and I think you're in for a real treat. I have 4 problems that were hand-picked by Mr. Ahrens, Mr. Rapoli, and myself. So without further ado, I'm going to write an equation that you may have seen before, and that is the equation of a circle. And this particular circle will have a radius of 3, so it's given by x squared plus y squared equals 9. Now what I want to be able to do is calculate the slope of the tangent line of this circle at any given point. So in order to find the slope of the tangent line, I need the derivative. Now in order to find the derivative, typically I would have an equation written as y equals f of x, and I'd take the derivative using all the rules we've used thus far. But I do not have an explicit equation for y. I have an implicit equation for y. So just to give us an idea of what we're working with, again, we've got a picture of a circle of radius 3, and it would be centered about the origin. And I want to be able to find the slope of some tangent line of that equation. Obviously, I didn't touch it very well. Now, I'm going to go through, and I'm going to take the derivative with respect to x of each side of this equation. Now, I'm going to rewrite this equation in a way that probably looks a little silly, and I'm going to put parentheses around my x and my y just so I can really ram home the fact that we're just doing chain rule. So I'm going to take the derivative with respect to x. Now when I take the derivative of something squared, I get 2 times that something to the first, and I leave the inside the same. And then I have to take the derivative of the inside. So I take the derivative of x with respect to x, which we know is 1. So this first part really just becomes 2x, exactly as we expected. Now when I get to the second term, I again get 2 times that something to the first, but then I take the derivative of the inside. Well, the derivative of y with respect to x is exactly what I want to find, so I don't know what that is. So I had to do chain rule. So again, I get the 2y just like I would expect, but I have chain rule says that I have the derivative of y with respect to x multiplied by that as well. Now something most people forget to do is that if I've taken the derivative of both things on the left side, I need to take the derivative of the right. Now the derivative of a constant is simply 0. So simplifying, I have 2x plus 2y times dy dx equals 0. Now I've done all the calculus, and it's an algebra problem, and I simply need to get dy dx by itself. So I'm going to subtract the 2x. I've got 2y dy dx equals negative 2x, and then I simply need to divide by the 2y. So I get dy dx equals negative 2x over 2y, which is simply negative x over y because the 2 over 2 simplifies to 1. So notice that this derivative involves both x and y. So at any given point, for example, the one where I drew that tangent line that isn't so tangent, that has some x value, right? Now, that x value also is down here. So I need to take into account that the y will come into play. So these two have clearly different slopes. One is positive, one is negative. That is because the derivative is dependent on both x and y. So let's take a look at another example. So I've got y squared equals 2x plus 3y. So again, I'm going to go through, I'm going to take my derivative. Derivative of y squared is 2y. But since y is a function of x, chain rule says I have to multiply by the derivative of y with respect to x. Then the derivative of the right side is simply 2 plus 3 times dy dx. So again, anytime I take the derivative of something with a y, I will end up with that dy dx. Now, this is just like algebra. I've got my variable on both sides. I want to get the dy dx on the same side. So I'm going to subtract 3 dy dx from both sides. So I've got 2y dy dx minus 3 dy dx equals 2. Now, since both of these terms on the left side have dy dx in them, I'm going to factor out dy dx, which leaves me with 2y minus 3. I've still got the 2 on the right side. Now I'm going to divide by 2y minus 3, and I end up with dy dx equals 2 over 2y minus 3. All right. On to the next problem. This is a little more involved. We're going to see product rule this time around. So 5x cubed y squared equals 3y cubed plus 4x. So again, if I look at the left side, I notice I've got a 5x cubed and a y squared. So I've got two functions being multiplied together. X is in the 5x cubed part, and y is a function of x, so that's why I have to use product rule. So I'm going to take the derivative of the 5x cubed, and I get 15x squared, which means I'm going to copy the y squared down, plus I'm going to copy my 5x cubed and take the derivative of y squared, which is 2y dy dx. So I'm done with the right side, sorry, the left side. And then on the right, I've got 9y squared dy dx plus 4. Now again, it's just an algebra problem. I'm going to move all my dy dx's to the left, and I'm going to move everything without a dy dx to the right. So I'm going to have 5x cubed, well, let's simplify that. 5 times the 2 gives me 10. So I'm going to have 10x cubed y minus the 9y squared. And I'm going to go ahead and factor out the dy dx because both of those things have dy dx in them because I purposefully moved them to the left side of the equation. And then I've got equals 4 minus 15x squared y squared. So again, I knew that both of these terms had dy dx in them, which is why I factored it out once I subtracted the 9y squared dy dx to the left side. I did 2 steps in one. Now I just have to do division. So I get dy dx equals 4 minus 15x squared y squared all over 10x cubed y minus 9y squared. So again, the only thing that changes is when I take the derivative of y, I have to remember to include my dy dx because I have to use chain rule. Now the last problem of the day involves a little trig. So we've got sine of y equals 7x squared plus 2. So again, take the derivative of the left side. Derivative of sine of something is cosine of that something. Now that something is y, so when I take the derivative of that inside, I get dy dx. On the right side, I've just got 14x. So again, I want to solve for dy dx, so I simply divide by cosine of y. So I get dy dx equals 14x, forgive my lag, 14x over cosine of y. So, I have for you some homework for you to have prepared for the next class. I want you to find dy dx given 4x squared plus 3x y squared equals 10. So again, this is your homework. Find the derivative of y with respect to x of this equation, 4x squared plus 3xy squared equals 10. Can't wait to see your answers. Have a wonderful day.